Here are the step-by-step solutions to problems 1 through 34 off of Review Gift 1. All right, so the first three were order of operations. So for number 1, the first thing we want to do is add what's inside the parentheses here. So we're going to get 10 squared, copy down everything else. Then we'll square the 10, so we're going to get 100 minus 16 divided by 2 times 4. So after we take care of parentheses and exponents, we want to do multiplication division left to right. And the reason we do this is because right now, this is like saying 100 minus 16 over 2 times 4. If we saw it this way, we would definitely know to divide the 16 by 2 first. So it's always multiplication division left to right. So this will become 100 minus 8 times 4. Then we do 100 minus 32, and here we're getting 68. All right, for number 2, we have several sets of parentheses. We want to do what's in the innermost part first. So we're looking at this, and of this part, we have to do the 7 times 2. So we're going to get negative 7 plus, and then in brackets, we still copy this. So we're first going to get 18 minus 14. After that, we still have to take care of the 18 minus 14. So we get 28 divided by 4. Even if we didn't have the brackets, they're not necessary at this point. We would divide first, so we would get negative 7 plus 7, which would give us 0. For number 3, there's no parentheses, so we want to take care of exponents. I could take care of both sets of exponents at the same time, so this becomes 16 plus 8 times 3. 2 cubed means 2 times 2 times 2, so that's going to give us an 8 minus 6. Next, we see a bunch of addition, subtraction, but we also have multiplication, so we have to do this first. So we get 16 plus 24 minus 8 minus 6. You could do the next one step at a time here. So we could do 16 plus 24. That'll give us 40 minus 8 minus 6. 40 minus 8 is 32. 32 minus 6 will give us 26. So that's how we do the first 3 problems of order of operations. All right, for number 4, we have this expression 8c plus ab all over d, where a is 4, b is 5, c is negative 0.5 or negative 1/2, and d is negative 3. So then this will become 8 times a negative 0.5, I'm going to write here as negative 1/2, plus a times b all over negative 3. So when I multiply positive times a negative, it's a negative, and half of 8 is 4, so we're going to get a negative 4. 4 times 5 is 20 over negative 3. So 20 minus 4 will give me 16. Negative 16 thirds. We could leave it just like that. All right, for number 5, we just have to simplify or evaluate what this is. So 4 minus 12 means you have $4, you owe 12. So it's really a negative 8. Now, if we go to our list of real numbers, types of real numbers, at the very bottom, we have natural numbers. Now, remember, natural numbers start with 1, 2, 3, so on. No fractions or decimals. This is not a natural number. It's also not a whole number because it's negative. It is an integer, and we use the letter Z or J to represent integers. It's also a rational number Q because we could put this as negative 8 over 1, and all numbers are real numbers. Number 6, we have radical 2 plus 3. We can't do anything with this, and because there's a radical 2, it's an irrational number I, and like I said, all numbers are real numbers. For 7, we have 3 cubed plus 10. 3 cubed is 27. 27 plus 10 is 37. So this is a natural number. It's a whole number. Because remember, natural numbers start 1, 2, 3, so on. So we would eventually hit 37. Same thing with whole numbers. They start with 0, 1, 2, 3, and so on. We would hit 37. It's an integer because, again, it's a whole number or its opposite. It's also a rational number because we could put it over 1, and it's a real number. And looking at number 8, we have 1/3 plus 1/4. We have to get common denominators here. So 3 and 4 can both go into 12. 3 gets multiplied by 4, so I multiply the 1 by 4. So we have 4 12s. 4 gets multiplied by 3, so does 1. So we have plus 3/12. So this will give us 7/12. All right, this is not a natural number. It's not a whole number. It's not an integer because those don't contain fractions. It is a rational number, Q, and a real number. All right, the next set, we're solving equations. So for number 9, we have 12z plus 36 equals 8z minus 48. All right, I want to start by subtracting 8z from both sides. So when I do that, I'll get a 4z plus 36 equals negative 48. Next, I want to subtract a 36. So I could do minus 36 here, minus 36 here. These cancel. I have 4z. Now, they're both negative, so it's like I owe both amounts. So if I added the 8 plus 6, that'll give me a 14, and then carry the 1 here. So again, it's like you could do this off to the side. You don't have to do everything just by looking at it in your head. If I were to add these two together, that's going to give me a 14, carry the 1. This will give me a negative 84 altogether. Then I want to divide both sides by 4. So in doing that, this will become a negative 21. Number 10, I have 14y minus 3 equals 25. I just want to start by adding 3 to each side. So 14y equals 28. Divide both sides by 14. So y equals 2. Number 11, we have 4 minus 2 times the quantity 1 minus w equals negative 38. Distribute a negative 2 carefully. So I'm going to get a negative 2. And then here I'm going to get a positive 2w equals negative 38. Combine the 4 minus 2, so we get 2 plus 2w equals negative 38. I want to subtract 2 from both sides. So I subtract a 2 from here, subtract a 2 from here. So these cancel. I have 2w equals, I owe 38 and I owe 2, so a negative 40. Divide by 2, and w equals negative 20. Remember, at any point, you guys can take the solution, carefully substitute it back into the equation, and it should be a true statement to let you know if you're correct. All right, number 12, we have some fractions. Here, I want to clear denominators. So here, the LCD, 10 and 5 is going to be 10. So what I want to do is multiply everything here by 10. So I'm just going to rewrite this, leaving some space. I'm going to write a 10 or a 10 over 1 in front of everything if I see a fraction. All right, so now this will become 40y minus the 10's divide out, so I'm left with the 1, equals 30y. And over here, 5 goes into itself, 1's into 10 twice, so I'm left with an 8. Next, I'm going to subtract 30y from both sides, so I get a 10y minus 1 equals 8. Add 1 to both sides, so 10y equals 9, and then divide by 10. So we do get a fraction, y equals 9/10. Okay, 13 just happened to be the same number, or the same answer here, but for a different reason. Again, I'm going to leave a little bit of space in between everything. Determine the LCD here. 3, 2, and 4 can all go into 12. So I'm going to multiply everything up here by 12. All right, so 3 goes into 12 4 times, so now I'm left with a 4x. 2 goes into 12 6 times, so now I'm left with a 6x. And 4 goes into 12 3 times. So 3 times 3 will give me a 9. So now I have 4x plus 6x equals 9. I can add 4x and 6x, get 10x. Divide by 10 again, so x equals 9/10. All right, there were a couple ways to do 14. I could start, the easiest way is to start by adding a 5x to both sides. So this will give me 6 equals 6x, divide by 6, so x equals 1. Or if you thought to maybe subtract an x from both sides, so subtracting an x here and then subtracting an x here, this will actually give me a negative 6x plus 6. But what do I write on the right side? There's nothing here, so 0. Next, I could subtract the 6 and then divide by negative 6, and I'm back at a positive 1. So a couple ways to carefully do that. All right, 15 through 18 were literal equations. So we have A is equal to P plus PRT we want to solve for t. So what I first want to do is subtract this p from both sides. So this just becomes a minus p equals PRT. Now to get rid of that PR, that's all multiplying, so I could divide by PR. And that'll do it. I'll have A minus P all over PR equals T. For 16, we have D times F minus 3G equals 4H. We want to solve for F. So I want to leave this term alone right now. I need to move that minus 3G to the other side. So now this becomes DF equals 4H plus 3G. Now to get the F by itself, I divide by D. I could leave all of this over D. So F equals 4H plus 3G all over D. All right, 17, we have 3a squared minus 1 over 2b equals c. We want to solve for b. So what I could first do is multiply both sides by 2b. Just get rid of that denominator. So what's going to happen over here is that they divide out. I'm left with 3a squared minus 1. I'll write this as 2bc. If I want to get the b by itself, I got to get rid of the 2 and the c, and I could do that by dividing by 2c. So now b is just going to equal 3a squared minus 1 all over 2c. 18, we have s equals 1/2 gt squared. We want to solve for g. All right, so here I have to be careful. I have this fraction here, which could make this look a little more complicated. To get rid of that fraction, I don't want to divide by it. So instead, we could multiply by the reciprocal, which would be 2. So I first want to multiply both sides by 2. So now I get a 2s, yes, these cancel out. It's going to equal gt squared. Now I want to solve for g, so I just got to get rid of the t squared. So I'm just going to divide both sides by that. So now g is equal to 2s over t squared. All right, for 19 through 25, these are absolute value equations. So first we have y minus 5 in the absolute value, minus 2 equals 10. I want to isolate the absolute value, so we get absolute value y minus 5, add 2 to each side, and now we can rewrite it without the absolute value bar. So we get y minus 5 is equal to a negative 12, or y minus 5 is equal to 12. Adding 5 to this side, we'll get y equals negative 7. Adding 5 to each side here, we'll get 17. And again, you can check these, but our solution is negative 7, 17. All right, for 20, we have absolute value of 2x minus 6 is equal to 14. It's already, the absolute value term is already isolated. So all I do is set 2x minus 6 equal to the opposite of 14, or 2x minus 6 is equal to 14. All right, so if I add 6 here, I'm going to get 2x is equal to a negative 8. Divide by 2, x is equal to negative 4. Add 6 to the other each side of the other equation, I get 2x is equal to 20, or x is equal to 10. So we get negative 4, 10 as our options. All right, for 21, again, we need to isolate the absolute value by subtracting 3, so we get x plus 4, absolute value of that is equal to 14. Now we rewrite it. X plus 4 is equal to negative 14, or x plus 4 is equal to positive 14. If I subtract 4 here, I'm going to get x is equal to negative 18. Over here, subtract 4, x is equal to 10. All right, for 22, we get absolute value of q minus 3 plus 7 is equal to 2. Again, I need to isolate the absolute value, subtract 7. But notice when I do, I'm going to get a negative 5. Right here, this is a special case, because I know what's on my left side, that's going to be positive, and I know the number on my right side is negative. Well, this is never true, so it's always a false statement, so I say no solution. 23, we have 2 times the absolute value of w plus 6 equals 10. I can't distribute into absolute value, so I start by dividing both sides by 2. Now I can rewrite it. W plus 6 could equal the opposite of 5, or w plus 6 is equal to 5. Subtracting 6 from this first equation, 6 from both sides, I'm going to get w equals negative 11. Subtracting 6 here, w equals a negative 1. All right, for 24, we get 4 times the absolute value of 3x plus 4 equals 4x plus 8. Again, in order to rewrite, my absolute value needs to be isolated, so I want to start by dividing both sides by 4, and when I do this over here individually, so now I get absolute value of 3x plus 4 is going to equal x plus 2. So now that I have an expression on that right side, I have to be careful. It's still the same process. I go to rewrite. 3x plus 4 is going to equal the opposite of x plus 2, or 3x plus 4 just equals x plus 2. So now, distributing the negative, I get 3x plus 4 is equal to the opposite of x, or negative x minus a 2. Continue to solve this. I'm going to add x to both sides, so this will give me 4x plus 4 equals negative 2. Subtract 4. 4x is going to equal negative 6. Divide by 4, but put this in lowest terms. X equals negative 3 halves. For the second equation, subtract x. I'll get 2x plus 4 equals 2. Subtract 4. 2x would equal a negative 2. Divide by 2. X equals a negative 1. Now we have to be careful. We want this side right here to be positive, but technically you should be substituting these values in. Now, if I added a negative 3 halves, which is really equal to negative 1.5, up here to 2, 2 is bigger, so that's still going to be positive, so this answer is good. And if I had a negative 1 plus 2, that's still positive, so this answer is good. But still, substitute them into the entire equation so we could keep both answers of negative 3 halves and negative 1. But 25 was a different story. We have 5 times the absolute value of 6 minus 5x equal to 15x minus 35. Just like the last one, I want to start by dividing everything up here by 5 individually over here. So I get absolute value of 6 minus 5x equals 3x minus 7. Separate this. 6 minus 5x equals the opposite of 3x minus 7, or 6 minus 5x equals 3x minus 7. All right, taking the opposite here, 6 minus 5x equals negative 3x plus 7. Let's add 5x to both sides. So 6 equals, this will give me a 2x plus 7. Next, I subtract 7 from both sides, so this will give me a negative 1 equals 2x. Divide by 2, so x is going to equal a negative 1 half. Over here, and we'll check this solution here in a little bit. Let's again add 5x, so we're going to get 6 equals an 8x minus 7. Adding 7, I'll get a 13 equals 8x. Divide by 8, so x equals 13/8. So what we could do, because if we know we did this step correctly, we could just go back up here. So if I were to substitute a negative 1 half in here, it'd be 3 times negative 1 half minus 7, which is negative 3 halves minus 7, which all I care about is a sign. It's still negative, so guess what? We can't use this. If I checked 13/8, I would have 3 times 13/8 minus 7. This will give me 39/8 minus 7. Now the question is 39 divided by 8 larger than 7? Well, think about it. 8 times 5 is 40, so 39 divided by 8 is going to be a little bit less than 5, which even if we did have 5, 5 minus 7 is still a negative answer, so I can't get a negative over here. So this is out. So what that tells me is neither solution worked, so I would have no solution. All right, on the back, we were looking at inequalities. So for 26, we have 5 times the quantity x minus 2 is less than 75. Here we can distribute the 5, so 5x minus 10 is less than 75. I can add 10, so 5x is less than 85. Now 85 divides by 5. If it's been a while since long division, all you have to do is take 85 divided by 5. Now notice it's positive, so I don't have to flip my inequality sign. 5 goes into 8 one time. 1 times 5 is 5. Subtract, that'll give me a 3. Bring down the 5. 5 goes into 35 7 times. 7 times 5 is 35 even, so I don't have a remainder. So here x will be less than 17. I put this on a number line. 17 is my special number. Open endpoint on 17. Since we're less than, shade to the left. Interval notation means negative infinity because we're going to the left forever, comma 17. Parentheses always around infinity, and parentheses around where we see an open endpoint. 27, we have 57 minus 4t greater than or equal to 13. Let's start by subtracting 57. So just to help, I'm going to write minus a 57 here. So we're going to get negative 4t is less than or equal to, and it's really 57 minus 13, but we keep it negative. So we'll get 44 here. Now I'm going to divide by a negative 4, so I have to flip my sign. And dividing negative 44 by negative 4, we're going to get an 11. Put my key number here. Closed endpoint on the 11. And we're less than, so again, we're going to end up shading to the left. Again, we'll get a negative infinity to 11, but a bracket here. All right, here again, a single inequality. We want to start by distributing the negative 3, so we'll get a negative 6x minus 15 is greater than 13x minus 4. I'm going to go ahead and add a 6x to both sides here, just to show you we don't always have to keep everything on the left side. So if I add 6, I'm going to get a 19x minus 4. Next, I want to add a 4 to both sides. So we'll get a negative 11 is greater than 19x. So now I want to divide by a positive 19. My sign will not flip. So x is going to be, and I'm reading it this way, x is going to be less than negative 11/19. Or if I flip this around, x is less than negative 11/19. So if I go to put this on a number line, again, I just need my fraction, my key number. This is going to be an open endpoint. And again, shade to the left. So we're at negative infinity to negative 11/19 in a parenthesis there. All right, another single inequality, distribute the negative 2. So 18 minus 2y minus 12 is less than 76. I can combine the 18 minus 12, so I'll get a negative 2y plus 6 is less than 76. Subtract 6, so negative 2y is less than 70. I am dividing by a negative 2, so I have to flip my inequality sign, and we'll get a negative 35. 70 divided by negative 2 is negative 35. Key number here, negative 35, open endpoint. This time we're greater than, so shade to the right. So here we start with a parenthesis, negative 35, because it's not included. It's a positive infinity if we keep increasing without stopping on the right. All right, 30 again is a single inequality. There's just a lot to do right here. 2 minus 3z is greater than or equal to 7 times the quantity 8 minus 2z plus 12. Keep everything on the left the same. Distribute the 7. 7 times 8 is 56. 7 times negative 2z minus 14z plus 12. Still keep 2 minus 3z on the right. 56 plus 12 is going to give us 68 minus 14z. I'm going to go ahead and add 14z to both sides. So 14z minus 3z or negative 3z plus 14z is going to give me a positive 11z greater than or equal to 68. Subtract 2 from each side, so 11z is greater than or equal to 66. Divide by 11, it's positive, so my sign stays the same, and I get z is greater than or equal to 6. 6 is my special number. Closed endpoint. Greater than means shade to the right. So I'm going to start with a bracket, 6, and then comma infinity with a parenthesis. 31, still a single inequality. Distribute the 8 first. So we'll get 16x minus 8 is greater than or equal to 11x minus 17. I'm going to subtract 11x from both sides. So this will give me a 5x minus 8 is greater than or equal to negative 17. Now if I add 8 to both sides, plus 8 plus 8, we have to be careful. So 5x is going to be greater than or equal to negative 17 plus 8 is negative 9. I'm going to divide by a positive 5 so I do not flip the sign. X is going to be greater than or equal to negative 9/5. Here's my special number. Again, a closed endpoint because it's or equal to, greater than, shade to the right. So I'll start with the bracket, negative 9/5 to positive infinity. All right, 32 is an in-between statement, so we're going to leave it as an in-between statement. But again, the way to read this is we start in the middle. 3x plus 2 is greater than 11, and 3x plus 2 is less than 20. So as long as we know how to read it, we could keep it this way and really start by subtracting 2 everywhere. So now we'll get a 9. So now 3x is greater than 9 and less than 18. Now I'm going to divide everything up here by a 3. It's positive, so I don't have to flip my signs. So now I'm going to get x is greater than 3 and less than 6. Now I have two special numbers on the number line, open endpoints on both of them, and we shade in between. So here I'm going to have parentheses, start at 3, go to 6, and another parenthesis. 33 definitely separated with an or. We have two inequalities here. 4x minus 10 is less than negative 10, or 6x plus 4 is greater than or equal to 10. So I'm going to start by adding 10 here, and be careful with what we're going to write. 4x is going to be less than negative 10 plus 10 is 0. When I divide by 4, it's positive, so I don't have to flip my sign, but 0 divided by anything is 0. Over here, I'll subtract 4 first, so we'll get 6x is greater than or equal to 6. Again, what I'm dividing by is positive, so x is greater than or equal to 1. So here I have my special numbers 0 and 1. Open endpoint on the 0, less than, so shade to the left. Close endpoint on the 1, greater than, so shade to the right. The interval notation, we're going to have two of them. We're going to start with a parenthesis, negative infinity to 0. It's not included, so parenthesis. To join these, we put the big union symbol here. Start with a bracket because the 1's included, and go to positive infinity with the parenthesis. And then finally our last one, 34. We have, again, how we read this, 3 times the quantity y minus 2 is greater than negative 1, and it's less than 9. So I want to start by distributing this 3. We get 3y minus 6. So now 3y minus 6 is greater than negative 1 and less than or equal to 9. Again, I could start by, or continue by adding 6 everywhere. So negative 1 plus 6 is 5, so we really get 3y is greater than 5 and less than or equal to 15. Divide by a positive 3, signs stay, so this will give me 5/3, so y is going to be greater than 5/3 and less than or equal to 5. On the number line, two key numbers, 5/3, 5. Open endpoint on the 5/3, but closed endpoint on the 5. We shade everywhere in between. So here we'll have a parentheses, 5/3, comma 5, but then a bracket. All right, so here are all the solutions up to 34. Let me know in the next Zoom meeting if you still have any questions.